Hello class, and welcome to today's lesson, which is about solving equations with variables on both sides. By the end of today's lesson, you will be able to solve different types of equations with variables on both sides. Quick review. When we are solving, we want to use SAD-MEEP as our solving technique. That first S standing for simplify, so whether that's distributive property or combining like terms, and then moving on to PEMDAS backwards, adding and subtracting first, then multiplying and dividing, then getting rid of any exponents, and then anything that was still in parentheses that couldn't be distributed. When you are dealing with variables on both sides, I have two tips or hints to remind you of. Make sure that you are combining the variables first. That simplify step becomes extremely important when you have variables on both sides. The more you can simplify, the more you can combine on each separate side before you start moving between sides is going to make your life easier. The second part, if possible, try and keep coefficients, those numbers in front of variables, positive. I find a lot of times when students are moving things from left to right or right to left, and there's a lot of things happening in an equation, one thing you can try to eliminate is negative signs. Your goal is to keep coefficients positive. It won't always happen, but if you can, that would be my suggestion. So, for example, I've got 52 minus 6x is equal to 49 plus 12x. First, I want to check if I can simplify anything. The left side, 52 and negative 6x can't go together. The right side, 49 and 12x can't go together. So I'm going to start by moving my variables from one side to the other. I want to try and keep my coefficients positive. Right now, that negative 6 is in front of my x. So I'm going to move that to the other side of my equation to make it a positive 6x to start. So I've got 52 is equal to 49 plus 18x. Now I'm into the multi-step problems that I was looking at yesterday, so I can go ahead and subtract 49 on both sides, and when I do that, that's going to give me 3 is equal to 18x, and to finish, I'm going to divide by 18. Now, since 3 actually can't be divided by 18, I'm going to just go ahead and reduce my fraction. So I'm going to have an answer of 1/6 is equal to x. Just like with all other variable problems, you can plug it back in to check your answer. So if I do 52 minus 6 times 1/6, I'm doing 52 minus 1/6 of 6 is 1. So I'm going to get an answer of 51. Then I would check the other side. I've got 49 plus 12 times 1/6. So I've got 49 plus 1/6 of 12 is 2, and I end up with 51. Both of my answers are equivalent, so that means both sides of the equation are equal, which means we have successfully solved the problem. Go ahead and try this one on your own. Starting by subtracting 4 on both sides to keep the variables positive, then subtract the 5 and divide by 3, we get an answer of a is equal to negative 6. Moving on to my next problem, I've got 7 times the quantity of n minus 2 plus 8 is equal to 3 times the difference of n and 4, subtracting 2. So the first thing I want to do is that simplifying step. I've got parentheses on both sides, so I can distribute to start. That's going to give me 7n minus 14 plus 8 is equal to 3n minus 12 minus 2. I can continue to simplify each individual side at this point. 7n minus 14 plus 8 is going to simplify down to 7n minus 6. Negative 14 and positive 8 gives me a negative 6. On the right side, I have 3n minus 12 and minus 2 more is going to give me negative 14 or subtracting 14. So before I moved anything from the left to the right or the right to the left, I simplified each side of my equation. Now I'm going to try and get my variables together to keep my coefficients positive. I'm going to subtract the 3n on both sides of my equation. So I've got 4n minus 6 is equal to negative 14. To get rid of my subtraction, I'm going to add 6 to both sides, which gives me 4n is equal to negative 8. And to finish my solving, I need to get rid of that 4. So I'm going to divide by 4 on both sides of my equation, and I get a value of n is equal to negative 2. Again, you could plug that back in to check it out to make sure that both sides are actually equal. And that's a great way to go back and check your work. Go ahead and try this one on your own. So we distribute the left side and then the right side. There's nothing else to combine, so then I can start moving between sides of the equation. Subtracting the 2q keeps the coefficient positive. Adding 70 and dividing by 5 gives me an answer of q is equal to 8. Moving on, if you have a fraction involved in your problem, the first thing we're going to want to do is remove that denominator. So it's saying n plus 7 is equal to 5n plus 45 over 3. I want to get rid of that over part so I can actually solve the problem. I'm going to go ahead and do that by multiplying 3 on both sides of the equation, which on the left side then is going to turn into a distributive property because I have an n and an addition of 7 occurring on that left side. So to get rid of that dividing by 3, I distribute on the left side, which is going to give me 3n plus 21. Then on the right side, the dividing by 3 just canceled out, and that leaves me with 5n plus 45. Now I'm going to get my variables to one side of the equation to keep it positive. I'm going to move the 3n by subtracting that on both sides. So I've got 21 is equal to 2n plus 45. Now I'm into my addition and subtraction part to get rid of adding. I'm going to subtract 45 on both sides. And when I do that, I'm going to end up with negative 24 is equal to 2n. And I'm going to finish by dividing both sides of my problem by 2, giving me an answer of negative 12 is equal to n. Once again, you could plug that back in to double check your answer. Go ahead and try this one on your own. We're going to start by multiplying both sides by 5, which gives us 12y plus 16 is equal to 20y. Combine my y's and divide by 8, I get an answer of y is equal to 2. If you are given figures, you're going to want to set up each part of the equation and then set them equal to each other. So it says find the value of x so that the figures have the same area. The first figure we have is a rectangle. In order to find the area of a rectangle, I need to do the base times the height. The base in this case is x plus 4, and I need to multiply that whole thing by the height, which is 5. On the right side, I have a triangle. The area of a triangle is 1/2 of the base, which in this case is 12, times the height, which is 2x minus 6. My next job is to simplify. So I'm going to go ahead and on the left side use my distributive property. So 5 times x is 5x plus 5 times 4 is 20. On the right side, before I can do my distributive property, I need to do the multiplication outside those parentheses. So half of 12 is going to give me 6, and that's what I'm going to distribute to both of my pieces. So I get 6 times 2, which is 12x, minus 6 times 6, which is 36. Then I'm going to go ahead and combine my variables by subtracting 5x on both sides of the problem. So my problem now reads 20 is equal to 7x minus 36. Going on to the next step, I'm going to add 36 to both sides of my problem, which is going to give me 56 is equal to 7x. And when I finish by dividing by 7 on both sides, I get an answer of 8 is equal to x. In this case, it doesn't give me an actual label. If it gave you a label such as 5 inches or 5 feet or whatever it is, you're going to want to make sure you include that label in your problem. Go ahead and try this one on your own. In this case, we have two rectangles. So the first one, base times height. On the second one, the base is 3 plus x. So that's going to be in parentheses times the height of 6. Do your distributive property, combining the variables and dividing. That's going to give me an answer of 4.5 centimeters. Last thing I want to address. Couple more specific types of answers you can get when you have variables on both sides. So I'm going to start by simplifying here. Distributive property is going to give me 6y minus 30 on the left side. And then when I distribute on the right side, I end up with 20 plus 6y. Like any other problem, my next job is going to be to combine those variables. So I'm going to subtract 6y on both sides, and that is going to give me negative 30 is equal to 20. At this point, all of the variables have been eliminated. 6y minus 6y is nothing, and on the right side, 6y minus 6y is nothing, leaving me with the statement of negative 30 is equal to 20. We know this is not a true statement. So the final answer to this problem would be no solution. This means whatever value of y you pick, it cannot make the two sides of the equation equal. On the flip side of that, in this case, when I distribute, I end up with 7x plus 5x minus 5. And on the right side, there's nothing to combine, so I have 12x minus 5. Now when I go back to my left side of my equation, I have 7x plus 5x, which is going to be 12x minus 5, is equal to 12x minus 5. When I subtract my 12x's from both sides of the equation, that's going to once again eliminate all the variables from the equation, but now my problem says negative 5 is equal to negative 5. This is known as the identity. What this means is that any value of x, so any number that you can think of, is a possible solution to this particular equation. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.